A Spring Boot app depends on several external services like a database, Redis cache, Prometheus for monitoring, etc. Docker Compose enables the Spring Boot app to start up these services automatically on Docker containers and wire up these services to your Spring Boot app with extreme ease. Spring Boot now has the Docker Compose starter, which helps package your entire environment together. In this video, we will quickly talk about what Docker Compose is and what value it provides. Then we will create a multi-container Spring Boot app from scratch, which uses Docker Compose to start and stop Docker containers for a PostgreSQL database and a Redis cache instance and wires it to our app. We will use Docker Desktop to examine our container instances. Please install Docker Desktop if you want to follow along. It is a very simple install and it installs the Docker Engine, Docker CLI, Docker Compose, among other tools as a part of its installation. Docker Compose is a tool for defining and running multi-container Docker applications. It uses a YAML file to configure the application's services, networks, and volumes. With Docker Compose, you can define multiple containers as services in a single file, start, stop, and manage all services together with simple commands, automatically create a shared network for the containers, and manage Docker storage volumes. Docker Compose simplifies the process of running applications that require multiple containers, such as a web application with a front-end, back-end, and database. It allows developers to define the entire application stack as code, making it easier to version control and reproduce the environment across different systems. In this app, we will have two Docker containers, one PostgreSQL and the other a Redis instance for caching, which Docker Compose will start and wire up to the app. Here, I am on start.spring.io. Let's choose Maven, name the artifact as Docker Compose Demo, add dependencies for JPA, PostgreSQL, Web, Spring Data Redis, and finally Docker Compose. Let us generate and download this. I have expanded the zip file and let's open it with IntelliJ. Open as a project. Looking at the pom.xml file, we see our dependencies here. Since we included Docker Compose starter also, it has created a compose.yaml file for us. Here, it outlines the services, Postgres with the latest image, environment values for DB, password, and user, which you can change if you want, and port. And similarly for Redis. Let's add to the ports. The first one is the internal port in the container, and we have exposed the same port from the outside. Here is our main application class. Let's look at the Docker Desktop running on my Mac. Currently, it does not have the containers for Postgres and Redis. Now, we have literally done nothing in our project. Let's run the app. From the console output, you can see that it is using the Docker Compose file, creates Docker containers from the images we had mentioned in the Compose file. It will download the images if they are not there. In my case, I already have the images, so it just starts them up and wires them to my project. Going back to the Docker Desktop, we now see a folder for our project Docker Compose Demo. If we expand it, we will see our two containers running over here. Let me stop the app. Going back to Docker Desktop, we see Docker Compose has automatically exited the containers. So how easy was it? Spring Boot Docker Compose starter, managing our Docker containers, and starting and stopping them for us. Cool. Now, let's demonstrate the usage of these services in our project to show how seamless the integration is. First, let's right-click on the top-level package. Choose New Package, name it Model. Right-click, choose New Class, call it Items. Mark it as an entity, have it implement serialization, create an ID named ID as int, and a private string item name. Let's generate the ID automatically with the generated value annotation with the generation type.identity strategy. Import the class. Right-click, generate getters setters, generate a constructor with item name, and another empty constructor. Next, let's right-click on the top-level package, choose New Package, call it Repository, right-click, New Interface, call it Items Interface, mark it as a repository, extends CRUD repository for items with ID of type int. Next, right-click, create new package controller, right-click, new class as items controller, mark it as a REST controller, auto-wire the items repository. Let's create a get mapping for /items, method public iterable items get all, inside iterable items as item repository.findAll method. With the system out, indicate get all items retrieved and then return the items. Going to the application.properties file, enter property Spring JPA hibernate.edl as create drop for Spring to create the items table on startup and drop when the app is stopped. Spring.jpa.show-sequel to true. Indicate that for spring.cache.type, we would be using Redis and the Redis host as localhost and the port as 6379, the port we mentioned in the compose.yaml file. To enable caching, go to the main class and add the @enable caching annotation, and now in the controller, mark the getAll method as cacheable with the value as items. Now we want to insert some values in the items table on startup. So going to the main class, let's implement command line runner, implement the run method. Inside the method, say running init database, auto-wire the repository, and using the item repository, insert two items, a table and a chair. When the app starts, the command line runner will run and insert these two rows in the items table. And the table will be created before that based on our properties in the application.properties file. Oh, let me correct the typos here. Cool, we're all set here. Let me run the app. Looking at the console output, the containers start, the table is created, and the two rows inserted. Going back to the Docker desktop for Postgres, let's interact with the container in the terminal. Type psql-u for user my user, -d for database, which is my database, the entries we had in our compose.yaml file, and we are connected to the Postgres database running in the container. Let's say select star from items, and we see our two rows over here. So our app was able to connect with the database and insert the rows in there. Going to the browser, type localhost:8080/items, and we see the two rows. Looking at the IntelliJ console, we see the method was called to fetch the rows from the database. Let's refresh the URL. We see the JSON output again. But this time, going to the IntelliJ console, we do not see the system out from the console, as it was cached in Redis the first time we called it, and the second call pulled it from the Redis cache. So both our services are wired successfully, and Docker Compose started and managed both the containers for us. In this video, we talked about what Docker Compose is and the benefits it imparts to our Spring Boot project. And then we created a Spring Boot app, creating a multi-container app using Hibernate and Redis. Thanks for watching.